so it ended and it took 82.286 seconds to do that sort. But now let me show you a different kind of sort that we can do that will be much faster. So all I'm going to do is I'm going to take my unsorted list and I'm going to break it into 10 different parts. But I need to count this in time as well. So first I'm going to set start time, print, I am now going to try splitting the unsorted list into buckets to see if I can speed up my sort. Okay, so I'm going to say print, just give a little space here. Then I'm going to say start time. All right, so now I've started my timer, and I'm going to go through every item in unsorted list. For number in unsorted. If number is less than 1,000, actually I'm going to create a bunch of unsorted, like kind of sublists. So I need to create some variables here. So I'm going to go back up here and I'm going to create 10 buckets. So bucket 1 is an empty list. Bucket 2 is an empty list. Bucket 3, bucket 4, bucket 5, bucket 6, bucket 7, bucket 8, bucket 9, and bucket 10. All right, so what I'm going to do is I'm going to go through each one of these numbers in the unsorted list. If the number is less than 1,000, remember every number is a maximum of 10,000. So if it's less than 1,000, I'm going to put it in bucket 1. Bucket 1 dot append number. Else, this means else if number is less than 2,000, I'm going to put it in bucket 2. And I'm going to do this for each one of these. So I'm going to go ahead and copy this. I think that might be enough. So bucket 2 is 2,000, this one is 3,000, and it goes into bucket 3. This one is 4,000, it goes into bucket 4. This one is 5,000, it goes into bucket 5. This one is 6,000, and it goes into bucket 6. 7,000 goes into bucket 7. 8,000 goes into bucket 8. 9,000 goes into bucket 9. And if it's bigger than that, it just goes into bucket 10. Else bucket 10 dot append slash number. So what I've done now is I've gone through all of the numbers in unsorted and I'm dropping them into these different buckets. So if it's under 1,000, it goes into bucket 1. It's still in random order in bucket 1, but it's adding them to each of these different buckets. Now what I'm going to do is I'm going to bubble sort each one of the buckets. All right, so now I'm going to say bucket 1 equals bubble sort bucket 1. Okay, and I'm going to do this for each one of my buckets. So I'm going to go ahead and do that. Oh, I don't want this for every number though. So I need to put this out. I don't want this to go in every number of unsorted because I've already dealt with all the unsorted. So now I'm sorting my buckets, and I'm going to go ahead and do this for bucket 2. I'm going to do this for bucket 3, bucket 4, bucket 5, bucket 6, bucket 7, bucket 8, bucket 9, bucket 10. All right, so 2, 3, 4, 5, 6, 7, 8, 9, 10. And these have to be 2, 3, 4, 5, 6, 7, 8, 9, 10. Now you may say to yourself, now wait a second, Mr. Maltzman, it's going to be the exact same amount of time because what I'm doing here is I've got my buckets and I'm doing the bubble sort on each of the buckets. I'm doing it 10 different times. So that's going to be the same speed as doing one big bubble sort. But the thing about bubble sort is it gets, I think, exponentially less efficient the larger the number is. So by breaking the number of numbers into smaller buckets, like each bucket on average should have 500 numbers because there are 5,000 numbers in all and there are 10 buckets. So each one of these buckets should only have 500 numbers. It should be a lot faster. And let's find out if it is. So what I'm going to do now is I need to take my result. And so my sorted list, sorted equals bucket 1 plus bucket 2 plus bucket 3 plus bucket 4 plus bucket 5 plus bucket 6 plus bucket 7 plus bucket 8 plus bucket 9 plus bucket 10. Okay, now I need to print the first 20 numbers of sorted. So, and I go here, I say print sorted list, copy this. Grab all that stuff, put it down here. So now it says print sorted list, first 20 does that again. End time equals time. The modified bubble sort with buckets took end time minus start time seconds. Okay, so the last one took 82 seconds, and this one, let's see how long this one's going to take. Hopefully it's not going to crash and I did nothing wrong, but I probably did. But let's find out. Okay, and it's the same list, by the way, so it should work. So here we go. First, it gives me my unsorted list. It gives me 20. So it proves that it has 20 unsorted numbers, and it's going to take 89 seconds to generate the sorted list, roughly 89 seconds. It'll be different each time, of course. But here it is doing its thing for 89 seconds. Are there any other jokes I can tell you? Let's see. Why don't fish like tennis? They get stuck in the net. Okay, here's another joke. What did Batman say to Robin right before Robin got in the car? Get in the car. So I think that's a funny joke because it's kind of like Batman's voice, like get in the car. Okay, but trust me, this is going to sort in roughly 89 seconds. And if I were smarter, I would pause this video and not talk to you while it's doing this, but you can look at the little spinning pizza thing. It's only 89 seconds around. Your life is going to be shorter by 89 seconds because you watch this, and I apologize for that. But here we go. Right, Snowy? Yeah, Dad. Snowy's sitting next to me. Can't see her, but she likes sitting next to me when I program. I don't really know why. She just kind of nuzzles in there. She's not a particularly good programmer. Whose fault is that, Dad? It's my fault, Snowy. Okay, so we're still doing, okay. So it sorted the first 20, and the bubble sort took 85 seconds instead of 89 seconds. And this modified sort with buckets took 5 seconds. Of course, why didn't it actually print anything? Oh, no. Oh, because I forgot to say I equals 0. I equals 0. I have to set that again. But it took 5 seconds to do it this time. So 85 seconds versus 5 seconds. And I'm going to do it one more time. You can either hang out for the next 85 seconds and watch it, or you can be like, no, I believe him. I'm not going to tell you any more jokes. Let's see. All right, how do I get this thing to run again? Boom, here it goes. It's going to generate my numbers. And then it's going to take 85 seconds. I wonder if there's a way to pause it. Can you pause it? Probably not. Pause the recording. I'll probably, I'd try to pause it and then I'd mess up the whole thing. And then I'd have to do it all again. Really what I want to do is have lunch right now. Hey, it's spring break. What are you doing for spring break? Well, I'm not doing much because I'm in quarantine, like you. So just kind of hanging out at home in the quarantine. Yep. Right, Snowy?
Yep, Dad.
Okay. Who knew that sorting numbers would be this fascinating? But if you really think about it, since you know that sorting has to do with everything you see on the internet, maybe it is more interesting. I hope. Supposedly, like when you have a job interview at a place like Google, one of the things they ask you is to write different sort algorithms. And now you at least know how to do bubble sort, which is probably the one they don't want you to do. But you could do the one where you break it into buckets too. And at least you could be, 15 times faster than the guy who did it, or gal who did it just with bubble sort. And there's a whole bunch of other ways to do sorting too. Gazillions. Here we go. We're still working on this. Do I have any more jokes? Probably not. Come on, baby. Oh, there we go. All right, the sorted list, the first 20, that took probably 85 seconds. And so the next one, the modified one, took 5.4 seconds. And we got the exact same results, 88 versus 5.4 seconds. That's pretty cool, right? That we were able to break it down. How many buckets do you need, by the way? You could experiment and say, what if I had 100 buckets? What if I had 3 buckets? How much faster would it be? And also, is the difference, so this is about a 13 times different, 14 times difference, 15, 16, 17 times difference. What if the number was shorter? So instead of doing 5,000 items, let's do 1,000 items, and it'll all be much faster. And let's see if it's still 15 times the difference. It won't be 15 times. It'll be much less than 15 times. So it did it in 4.17 seconds, and this time it did it in 0.48 seconds. So it was a 10 times difference, okay? And this shows you that bubble sort gets less and less efficient as you have more numbers. So if you only had 500 numbers to sort, instead of 10,000 or 5,000 or whatever, if you only had 500 numbers to sort, the whole thing is going to be really fast. And it did it in 1.3 seconds with bubble sort, and with modified bubble, it did it in 0.31, so like 4 times faster, but not 15 times faster. And if you want to do some huge number like 1 million and see how long that would take, it would take a long time. In fact, you know what I'm going to do? I am going to set it up to sort, 50,000 or 100,000 numbers, and then I'm going to have lunch, and I'm going to come back, and I'm going to tell you how long it took and what the difference was. Ah, how exciting is that? Oh, it's so cool.